Welcome to Northern Chemistry. Today we're going to be doing alcohols exam questions. Feel free to go ahead and answer the exam questions and then run through the video with your answers. I'll put the link in the description. Question 1. Alcohols can be used to prepare organic compounds with different functional groups. So we've got a dialcohol which can be oxidized to form a dicarboxylic acid. State the reagents and conditions and write an equation for this reaction. In the equation, use O in brackets for the oxidizing agent. So the reagents and conditions, so we have a primary alcohol and we need to form a carboxylic acid. So that's going to require full oxidation of the primary alcohol. So we're going to need excess acidified potassium dichromate, which is the oxidizing agent, and then we need to heat under reflux. If you are trying to just make an aldehyde, then you need to distill immediately in order to prevent further oxidation. Then in our equation we need to use structural formulae to write out the equation. And since we have two alcohol groups and we need to do full oxidation, we need to balance with 4 oxidizing agents. So that's 2 oxidizing agents per alcohol group, which is going to form the product, the dicarboxylic acid, and 2 molecules of water. So the dicarboxylic acid is soluble in water. Explain using a label diagram why the dicarboxylic acid is soluble in water. So this is due to hydrogen bonding, so we need to draw a diagram to show hydrogen bonds between water molecules and the dicarboxylic acid. So when we're drawing diagrams for hydrogen bonding, we always need to label the hydrogen bonds. And don't forget to draw your dipoles on the bonding atoms. So hydrogen bonds are the strongest intermolecular force, and they act between the lone pairs on the highly electronegative oxygen atom and the delta positive hydrogen atom. Question 2. This question is about the alcohols A to F shown below. Which of the alcohols are secondary alcohols? So if you have a look at A, we can see that the carbon it's attached to is only attached to one other carbon atom. So that's a primary alcohol, so it's not A. B, we can see that the carbon it's attached to is attached to 1, 2, 3 carbon atoms, so that's a tertiary alcohol. C is a secondary alcohol because it has the carbon that the alcohol group is attached to is attached to 2 carbons. Then D is a primary alcohol again because the alcohol group is attached to is only attached to 1 carbon atom. E is the secondary alcohol. And then F is also a secondary alcohol. Question 3. This question is about alcohols and alkanes. 3 alcohols, A, B and C, are structural isomers of C4H10. Each alcohol is refluxed with acidified dichromate. Draw the structures for the organic products. If there is no reaction, write none. So we know acidified dichromate is our oxidizing agent. And if we look at A, we know that's a primary alcohol. B is a tertiary alcohol, so that's going to resist oxidation. So we can just write none for that because tertiary alcohols cannot be oxidized. And then C is a secondary alcohol. So then we know that if we're refluxing with acidified dichromate and a primary alcohol, we're going to form a carboxylic acid. So let's draw the correct structure. And then C is a secondary alcohol, so it's going to form a ketone when it's oxidized. Write the systematic name for alcohol C. So if we draw our alcohol C, we can see that we've got a chain of 4 carbon atoms, 1, 2, 3, 4, and the alcohol group is at position 2, so it's butan-2-ol. Complete the equation below for the complete combustion of alcohol A. So in combustion, the fuel reacts with oxygen and forms carbon dioxide when it's complete combustion and water. And then when we're balancing combustion equations, we want to start with the carbons, so we'll balance the CO2 by putting a 4 in front of it. Then we want to balance the hydrogens, so we balance them by putting a 5 in front of the H2O. And then we want to balance, finally, the oxygens. So we can see on the right hand side of the equation, we have 8 oxygens in CO2 and 5 in water. So that gives us a total of 13 oxygen atoms on the right. And then if we subtract 1 from that for our alcohol, that leaves us with 12 alcohols to balance. So we need to put a 6 in front of the oxygen. This question is about reactions involving alcohols. 3 reactions of an alcohol E are shown in figure 25.1. Complete figure 25.1 to show the structures of the organic products formed in the reactions. So, in this first reaction we have sulfuric acid and heat. So that's going to eliminate the alcohol group from our alcohol and dehydrate it, forming an alkene bond. And then with acidified potassium dichromate, we have distilled and refluxed. So when we're distilling a primary alcohol, we form an aldehyde because only partial oxidation occurs. So when we distill it, we remove it from the reaction mixture and the aldehyde is formed on its own. So further oxidation of the aldehyde doesn't form a carboxylic acid. And then when we reflux it, we're going to form a carboxylic acid because full oxidation is allowed to occur. What is the systematic name of alcohol E? So let's draw out alcohol E. So you can see that the longest chain is 1, 2, 3 carbon atoms, and we have a branching at position 2. So it's 2-methyl, and then the alcohol group is at position 1, so it's 2-methyl propan 1-ol. Thanks for watching. Be sure to check out my website. I've got lots of resources available for purchase, including my A-Level Chemistry notes and flashcards, of which there are 899. You can also book a tutoring session, send me a message and I'll book you in straight away. Be sure to check out my other videos. I've got an alkenes exam question walkthrough to check out up for you in the top corner.